All right, so here's a problem. Now go ahead and pause and try and solve it. All right, so it says that we've got a pipe closed at one end and it produces a fundamental frequency of 220 hertz. What is the frequency of the third harmonic? So this is a very straightforward, I think very simple problem. Might be a little bit more, you might overthink it. It's very easy to overthink it. So let's go ahead and draw a pipe, what it would look like. As we've said before, its fundamental frequency is the smallest we can fit a wave in. So it would look something like that. Let me fix that. Right? So again, that's going to kind of go like that. And make sure to watch the full video that I did on this to understand what I'm doing here. Right? And so what is the third harmonic? Well, the third harmonic is going to have a frequency that's 3 times the frequency of the first harmonic, the fundamental frequency. Right? So it's just going to be 3 times 220 hertz or 660 hertz. And really the way that I would recommend you think about this is you can think about this in terms of the wavelength, right? So the wavelength of 4L divided by, remember the equation for this is 4L divided by N, and that's going to be equal to the wavelength, right? So the wavelength of the first harmonic, so the wavelength for 1 is equal to 4L divided by 1, that's just going to be 4L, right? And then the wavelength of the third harmonic, let me fix that. It's going to be equal to 4/3 L, right? So essentially the third harmonic's wavelength is going to be 1/3 of the wavelength of the first harmonic, right? And because frequency and wavelength are inverse, if the wavelength here is 1/3 of the wavelength here, then the wavelength, then the frequency is going to be 3 times it, right? So the frequency here is going to be 3 times the frequency here, right? Because again, it is inverted. So the correct answer is going to be B, right? I think a fairly straightforward problem, both from a conceptual standpoint and mathematically. So really, if you're overthinking this problem, it's gonna be a little bit harder. When you think it just in terms of the harmonics, you understand that the harmonics are going to be multiples of the fundamental frequency. And that's the case for the wavelength as well as the frequency. And so understanding it in that sense, this, for example, would be the second harmonic, right? So this is the second harmonic. But of course, this can't have a second harmonic because it's closed at one end. So this wouldn't really be a harmonic. It wouldn't exist, right? And so the correct answer here is going to be B. B is the third harmonic.